Hi Calculus, welcome to week 1 where we're going to work with rates of change. Your book gives the following formula to find rates of change. You might be looking at this formula and asking yourself, what does that really mean? Basically, what we're going to do when asked to find the average rate of change is to select a small interval around the desired time. Often it will specify for you what range they want you to use. If they don't, start with a range of 0.1 or possibly down to 0.01. You're going to put these times into the function and find the values that the function gives you. Finding the difference between those and then dividing by the difference between the two times will give us the average rate of change. Let's look at an example. If we have an equation for the height of a rock, the height of a rock thrown into the air is given by h of x equals negative x squared plus 8x plus 2. This is measured in feet, where x is in seconds. You might be asked to find the average rate of change from 3 to 3.1 seconds. To do this, we first need to evaluate our function for our 2 points. So if we look at h of 3.1, we're going to substitute that into the equation. So negative 3.1 squared plus 8 times 3.1 plus 2. Using your calculator to evaluate that will give you a value of 17.19. Now let's find h of 3. Once again, we're going to substitute 3 into our equation for x. Evaluating that gives you a value of 17. Now, if you remember in our formula, we're looking for the difference between those divided by the difference of time. So really what we want to do is take our h of 3.1 minus h of 3 and divide that by our difference in time, which is 3.1 minus 3. So in other words, we're going to take 17.19 minus 17, divide that by 0.1. That gives us an average rate of change of 1.9 feet per second. We're also going to look at the instantaneous rate of change. This is the limit of our average rate of change as x approaches a given value. Now when we find average rate of change, that's found in an interval. Instantaneous rate of change is for a specific point in time. Basically, to find this, we're going to use smaller and smaller intervals and see what they are approaching. So if we're looking at the same equation with the same formula, h of x equals negative x squared plus 8x plus 2, let's see what happens if we look at a smaller interval from 3 seconds to 3.01. So let's evaluate and see what happens when we put 3.01 into our equation. So we have negative 3.01 squared plus 8 times 3.01 plus 2. And that gives us a value of 17.0199. Using our previous equation, we knew that the value of h of 3 was 17. So we can take 17.0199 minus 17, divide that by our change in time, which is 3.01 minus 3. That means we have 0.0199 divided by 0.01. That means at this point in time, our average rate of change is 1.99 feet per second. We still haven't found the instantaneous rate of change. We could get a smaller interval, or you could probably see that from our past problem where we had a bigger interval and our average rate of change was 1.9 feet per second. Here we're at 1.99 feet per second. So our instantaneous rate is approaching 2 feet per second. Rate of change is a big part of calculus. I hope that you enjoy these examples. If you have any questions, please give me a call. Thank you.